Okay, so let's look at a problem involving areas between lines. I'm going to draw a little sketch here of a curve. And before we would have been able to get the area under this curve by knowing what the equation of the curve is and knowing what are called the limits at either end, so knowing where it starts and where it ends, the area that we would do that. And we would get the area by integrating this curve, and then when we integrate it, we would have two limits to sub in, so we'd sub in 6 and 0, and work out the difference between those two values, and then that would give us our area. In this example, we're going to combine some skills that we've learned over the course of the year, and we're going to put them together. Essentially, I'm going to take that same curve, which is y is equal to 6x minus x squared, and I'm going to combine it with another line, this line being y is equal to 2x. And what we're going to do is we're going to find the area between those two curves. Now, there are a number of stages to this, and I'll detail the stages before we do anything else. As we just seen previously, to be able to integrate, we needed two things. We needed the curve, or the area that we need to integrate. We need an expression for that to integrate, and we also needed limits. Now, to get the limits here, the limits aren't necessarily given to us in the question. Now, I've drawn this badly, but that's supposed to be at 0 there. We can probably guess one, but we don't know both. So the first step that we're going to do is we're going to solve the two lines, one being a curve and a line, simultaneously. To get x values. Okay, and what this will do is it'll give us limits for our integration. Now, in both of these cases, or usually in these cases, this is actually a bit easier than it would normally be, because we have one linear and one quadratic function, this being the quadratic and this being the linear, but both are equal to y. When we were doing this before, I would have got you to replace anything that's y in the first equation with 2x, but because they're both equal to y, I can essentially just make them equal to each other. So if y is equal to 6x minus x squared and y is equal to 2x, then we can make them equal to each other. And to solve things simultaneously, I need to rearrange so that everything is equal to 0. So if I do that, I can bring my 6x to the left, I can bring my minus x squared to the left, and that will give me 2x. The plus 6x will become a minus 6x, and the plus x, or the minus x squared, will become a plus x squared. And I will get an expression like so, equal to 0. X squared minus 4x is equal to 0. To factorize this, I can do it by hand, or I know an awful lot of students are just using at this stage the quadratic formula, which is minus b plus or minus the square root of b squared minus 4ac all over 2a, where I need to pick a values, b values, and c values from my equation. A is the value of the x squared, which in this case is just 1. B is the value of the x, which is minus 4. And c would be the value of the constant at the end, but in this case that is 0. And you can plug those values in your equation. Times 0 all over 2 times 1. When I do that, I will get two values for x. I will get 0 and 4. And if I go back up, that gives me what my limits are. for my integration. So that is step 1 done. Step 2 is from our two expressions, we're going to create a single expression to integrate. Now, be clear, there are two methods you could do this, but I find this one much more straightforward, because we could just integrate both of our expressions separately. So we could integrate the 6x minus x squared between 4 and 0, and then integrate the 2x between 4 and 0 and subtract them. But we will create a new expression by taking the top part of the shaded region minus the bottom part of the shaded region. So let's look. If I look back at my original curve up here, what do you see? Is the top part of the shaded region a curve or a straight line? And hopefully you'll be able to see that it is actually a curve. This bit here is a curve. The bottom part is a straight line. So the top part is the curve and the bottom part is the straight line. So if I use that, my expression for the top part is 6x minus x squared. Oops. Let's use the proper pen. So it'll be 6x minus x squared. And then I'm going to take away the bottom part, which was a straight line, which is 2x. If I sort that out and remove my brackets, the minus multiplies into the 2x to give me minus 2x. And I will get 4x minus x squared. And there is my new expression. Third step is to integrate between the limits to get the area. So just like all the other examples where we would integrate, our limits are between 4 and 0 from first part of our question. Our expression is 4x minus x squared. And we're going to integrate this. When I integrate 4x, it's really 4x to the power of 1. So that becomes 4x to the power of 2. And I divide by that new power, which is 2. And I take away x2 becomes x to the 3. Divide by 3. And I do that between 4 and 0. I could simplify down the 4x squared over 2. But since I'm going to pop it into my calculator in anyway, it doesn't entirely matter. I'm going to replace all the x values with a 4. I plop that into my calculator. I'll get 32 over 3. If I do the same for 0, I'll replace the x with a 0. And I'll get 0. My area is then going to be the first value, which is 32 over 3, minus the second value, which is 0. And my answer for the area between these two bits is 32 over 3 square units. There's more practice in the middle, and I hope that was some